All right, so we are going to start by doing another example, which I did not include in the notes. So it's sketched the following function. Really, what we need to do is we need to sort of get a handle of what's going on here. This is a crazy polynomial function. So I'm just going to pick out information. Relevant information is often degree. Degree is important. Leading coefficient is important. Other information that are important are the zeros, are the x-intercepts. And I'm just going to put 3 bullets, one for a single, right, for the multiplicities, one for the double, and one for the triple here, if they exist. So allow me to get back to the question here. So what degree is this? Well, the exponent here, the degree, it takes a little bit of imagination. But if I multiplied all of these factors out, what would the final exponent be in my polynomial? Well, x to the power of 1 times x to the power of 2 times x to the power of 3. Now, when we're multiplying variables, we simply add the exponents. 1 plus 2 plus 2, so this is a degree 5. Maybe I should change colors to make that more vibrant. My leading coefficient is going to be negative. The leading coefficient is negative. And we can see that by there's going to be a negative. If you want, if you don't believe me, you can multiply all this out and it'll be a lot of fun. But my leading coefficient is negative. And then I look towards the factors and I use these factor theorem. Since I have a factor at x minus 2, that means that I have an x-intercept at 2. Since the factor is only repeated once, that would be a single 0 at 2. Here, I have a factor of x plus 1. That implies that I have a 0 or x-intercept at negative 1. And since this factor occurs twice, that it would be a double 0. Now I have another factor at x plus 3. This implies that I have an x-intercept at negative 3. Since this factor occurs twice, this is another double 0. And normally I like to make my shapes a little bit different. Now this is just my own invention. So I have a single 0 at 2. So I'm going to put a little dot there. So I know that this is a single 0. A double 0 I make square. So I have 2 double zeros, one at negative 1, and one at negative 3. Now this is just to help me out here. So, and now I ask myself, this is an odd degree. Sorry, that's very bad writing. This is an odd degree function with a negative leading coefficient. Overall, this has the left-hand and right-hand side behavior that my function is decreasing on the left and the right. So I call this a sketch. If you notice on my y-axis, I have no indication of scale. It's because this function will get big and nasty in a hurry. So as my function on the left, it is going to be a decreasing function. I hit a double 0 at negative 3, and it bounces off the x-axis. That's how I start this off. And now, since it bounced off the x-axis, I'm going to try to turn this around. I have to hit this other double 0. I hit it. And my function's bouncing upwards. Now, you and I know that I can determine my y-intercept here, and my y-intercept, if I just do the math quickly in my head, it looks like it's going to be positive 18. But instead of doing that, I'm just going to make sure that it goes up and I'm just going to ignore that there's any y-intercept meaningfully. This is a sketch after all. Now, this 2 is a single 0. So my function turns and should burn right through that single 0. And isn't it interesting that I observed the behavior of your singles and double zeros? And what ended up happening on the right-hand side is that my graph observed the left-hand and right-hand side behavior of a polynomial. All right, next example. So I'm going to press pause here, and I would like you to pick out the relevant information that you see fit. Do this. Now you may have noticed what I've done here is I've said, oh, degree, leading coefficient, those are important. My zeros, single, double, triple. I think that this is a good template to work off of. My degree for this polynomial is going to be, allow me to say this is degree 3, or a factor of degree 3, a factor of degree 2, a factor of degree 1, which makes this x to the power 3, x to the power of 2 times x to the power of 1, makes a 6th degree polynomial. My leading coefficient, if I multiply all of this out, I know that my leading coefficient will be positive. That is, there is no negative term in any of these. My zeros, so do I have a single 0, a double 0, a triple 0? I know that, look at this. This is x plus 3. I know that I should have a single 0 at negative 3. So I'm going to make this a dot. A double 0, oh, look here. X plus 1 is a factor that occurs twice. So I know that I have a double 0 at negative 1 using the 0 or the factor theorem. X minus 4, this factor occurs 3 times, so it's a triple 0. But x minus 4 is a factor. This implies that 4 is a triple 0. Now, to graph this, not sketch, to actually make a graph is very, very difficult. So just quickly in my head, I'm thinking that my y-intercept will be negative 192. So this function goes really high up and down and all over the place. So at best, what can we do? Just get the shape. So this is an even degree function with a positive leading coefficient. On the left-hand side, it's going to look like that. On the right-hand side, it's going to look like that. Right? Now, it has a single 0 at negative 3, so I'm going to make that a round dot. A double 0, I'm going to make this square, why not? Well, this is just to really tell me to slow down my thinking and pay attention to what's going on in the graph. My mistakes in math are often due to inattention. A triple 0 at 4, I'm going to put a triangle there. Now, everybody else in the world will look at this and be like, dot, square, triangle, those don't mean anything. Okay, they're just for me. The left-hand side behavior, what we see is the graph is decreasing on the left. I've indicated that I have a single 0 at negative 3, so my graph must go through the x-axis. That's the behavior of a single 0. A double 0 at negative 1. So now a double 0 at negative 1, my graph actually bounces off. Oh, good. Good. That's superb, right? So it bounces off. And now I have a triple 0 over there. Now, I have to turn around this bus and go through that triple 0. What happens at a triple 0, it flattens out, but still goes through the x-axis. There we have it. There's my polynomial function as described by these factors. If you do it correctly, your resulting function should observe the left-hand and right-hand side behavior that you indicated at the beginning of the question. Let me know if there are any additional questions.